there's a really large loop running inside that physics engine. Every instance of a second, the physics engine is updating, seeing what happens. There's also another loop happening, which is the game loop. And the game loop doesn't happen every time the physics engine happens. The game loop happens at a slower rate, but still, that's your frame rate, your rate per second that you're doing to be able to animate and project on the screen. Every time that happens, the objects look at themselves and say, what are my components? We've been throwing on components of rigid bodies and throwing on all these other pieces to these objects with textures and shaders and other parts that always get looked at every time and try to figure out what is going on with them. So those are scripts underneath. We don't really get to look at those, but we can start adding our own. And what we are trying to do is subclass something called a mono behavior. We're going to be writing in C# as we start scripting in this class to make our objects interactive. And this looks very, very, very similar to Java. It is pretty much Java with a French accent, is the way to think about C#. Public class, mouse look, this is the name of our class, instantiates the mono behavior. You do that with a colon. But, hey, you've got curly braces. You've got the words public, private. We, in C#, and especially in Unity, we want to use float. We don't want to use doubles. You probably just ingrained yourself to use doubles as you programmed in Java, because doubles are better. They're twice as big. But in terms of speed and optimization, most things that care about doing stuff quickly think about floats. So it's nice. You're going to want to write in floats all the time, but it's frustrating because every time you do, you're going to have to put the letter F after it. Every single number you write, every single decimal place you actually make an actual number, you're going to have to use an F. Otherwise, it's going to complain at you. It'll say, wait, this is the wrong size. This is not right. But almost everything in Unity uses floats as its currency of floating point numbers, not doubles. So that's one thing you're just going to train yourself to do. So there's two methods that come with a mono behavior that we are going to be overriding every time. There is the start method. Let's shrink this down so we can actually see it. See if I can shrink a window today. Nope. 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 Yes. Okay. So there is the start method and there is the update method. Whenever Unity loads, it does the start method once on an object, and then it does the update method. Every single frame per second. It runs it and says, what should be going on? What should I be doing? How should I change stuff? So let's see what this script does of how does it figure out what the mouse is doing. Let's just walk through a bit of C# and try to read it and see what's happening. All this stuff up here, data members, the fields of this object. How can we see what these are in Unity? Let's look at all the names here. Rotation axes, sensitivity X, sensitivity Y, minimum X, minimum Y, maximum X, maximum Y. Where are those? Let's go back and look at our character controller that we have running around here. On the right hand side now we get a box that says, here's my script for mouse look. And everything we declared as a public piece over here shows up for us to start changing as the designer. This is where the developers and designers really start to work together. You're going to be coding scripts that say this is a type of object that has these attributes and has some methods inside it and does things, and then a designer would use your object to drag it in there, change these, say, oh, I want the sensitivity of the X and the Y to be this, minimum X, minimum Y to be that. And then you write the program to react to those numbers. If you don't declare it public, then you can't see it in Unity. You can't change that number as the designer making your game. So make sure those are public. The things that you want to be changing, not in code all the time, but as you're playing with this object, as you're moving around, what's going on with it. Okay, so what does it do? It says if the person that's using this object selected mouse X and Y, go talk to, let's see if I can shrink something here. Yes, wonderful. Go run through these lines. What does that mean to you? What is this code doing? Sure, you've never read C# before, but you've read code. It looks like Java. Seriously, just fake yourself. It's Java. What does this do in Java? What is changing?
X and Y position of the mouse.
It gets the X and Y position of the mouse from input. It gets the X position. It gets the Y position. So this is how a script can talk to the mouse. Give me a number. Where is the X? Where is the Y on the screen? Any script can ask for that with this capital input.getAxis, mouse X, or mouse Y. So that's really convenient for us. It recalibrates it and says rotation Y equals this times that sensitivity. And then math F, there's another F showing up. You don't just use the math module, you use the math F module, because everything is floats. And it will just catch you every day that you're not using doubles, you're using floats. So math F is really important. We're going to clamp this rotation that I just calculated based on the minimum and the maximum value for it. Make sure you don't exceed these numbers that somebody typed in. Minimum, maximum X, minimum, maximum Y. This is what's happening. Then, what else is going on there? There's some new things you probably haven't seen before. What's new? Vector 3. Right. We want to make points. We want to make things that have 3 coordinates. X, Y, Z. Or rotations. Right? Everything that we've seen so far, every game object we created has this transform. Transform is an essential piece of a game object, and a mono behavior that we're programming here assumes that we have a transform, and we can just talk to it. Because we inherited and said we are a mono behavior, it knows that one of those previous public variables that's available for us is called transform. It's just there for us. So the transform needs to know what are my angles going to be. Give me 3 coordinates of vector 3, y, x, and 0. Does that make sense? Questions about that? Yeah.
What specifically does the local Euler angles attribute on that? Is it just the way that it does the math? So that the way you move the mouse is even across that angle? What was the point, I guess?
Yes.
Why is that what it changes?
So here is something really crazy about games and rotations. We think these transforms are nice and straightforward. Position, x, y, z, rotation in these 3 angles, 3 dimensions. What is my rotation angle? That would be super easy for us to do, but we get problems sometimes when we're trying to say, if I'm here and I want to be there, what angle, what rotation should I use to point myself in that direction instead of this one? This involves some higher level math to get done, not just three-dimensional vectors, but to really make it work, we've got to do something else crazy. So let's walk through some of those strange things. Okay, so let's talk about gimbal lock. Gimbal lock happens when you've got some three-dimensional mechanism and you're trying to rotate and move things, but two of the axes somehow get in parallel and then get stuck, and they move together. See if we can get a nice animation here. Yes. So this is a really cool gimbal. Everything is rotating independently. Everything is wonderful. But we could get a spot where, oh no, we move things and then we try to rotate things in the other dimension and these are stuck together. The math doesn't work as well with just 3 dimensions, and trying to do the linear algebra on 3 dimensions with rotations, that you have to go to the 4th dimension. We have to uncover some strange new piece of mathematics that was discovered back in, when was it, 1843, called a quaternion. Has anybody heard of quaternions before? Somewhat, maybe. I just heard the word. Never. I understand completely. I didn't even know what they were until I started programming Unity. But you're like, no, they're mathematical objects, and they're related to the complex numbers. Who's heard of the complex numbers? Many of you, hopefully, raise your hands. Complex numbers, yeah. So what is a complex number? Imaginary numbers. Yes, real and imaginary numbers. And there's a strange thing, you can use complex numbers and plot them on a 2-dimensional plane. You might have seen some fractal images of Newton's method. Let's see. Newton's method, fractal. These images, if you've ever seen them, are based on finding roots to equations, and those roots might involve complex numbers, and you get some really strange fractal patterns, and if you're using those complex numbers, you can plot them on a 2-dimensional plane and really see where those numbers end up and what the patterns of attraction are for those fractals. So it doesn't seem exactly related, but somehow complex numbers are related to a 2-dimensional projection. Quaternions that they've discovered are a 4-dimensional representation that can help us out with 3-dimensional rotation mechanics in space. The way that you can multiply these numbers is equivalent to the rotations that we need to understand. So what Unity has done is spent the huge amount of work programming a quaternion, making the quaternions work under the surface, and we just have to use them as if we're thinking of these angles moving around. So back to Connor's original question, local Euler angles here is talking about this transforms quaternion from the perspective of the angles we're used to. Angles going from 0 to 360. Because Unity lets us do quaternions. They're nice, compact, very fast equations, don't suffer from gimbal lock. You can interpolate them. You can say, I want to be here and there, and you interpolate as you go and figure out what those angles are. But it's based on 4 numbers, 4 dimensions, x, y, z, and w. You never access or modify them. They're there, but don't really talk about them. Underneath the surface, we really just need to talk about the Euler angles, the 3 dimensions that we're used to thinking of an angle in. And it helps us out. So, sort of a long answer, but it gets to